Welcome to our section on square roots. Okay, what we're going to do here is we're going to look at some integers that are perfect squares, and then we're going to look at how we take the square root of integers that are not perfect squares. So let's get started. Let's say we want to find the square root of 121. Okay, when we want to find the square root of a number, what we want to do is we want to start with what we know. If we don't have it memorized, we need to figure out what two numbers will multiply together to get 121. Okay, well let's think about this for a second. We know that 10 times 10 equals 100, and that's pretty close to 121. So just giving a trial and error estimate, we know that the square root of 121 is going to be just above 10. So let's try 11 times 11. And 11 times 11 will give us, we can even check with a calculator, is 121. So the square root of 121 is 11. Okay, let's do another one. Let's say we want to find the square root of 441. I don't have this memorized, so we're going to start with what we know. Well, we know that 20 times 20 equals 400. So that's kind of in the ballpark, 20 is. So let's try 21. 21 times 21 turns out to be 441. Well, two numbers that multiply together to give you 441 is actually what the square root of 441 is. It's 21. Okay? We want two numbers that will multiply together will give us the square root of that answer. We want to know the square root of 324. Square root of 324, well, again, we know 20 times 20 is 400, so I'm thinking the square root of 324 is going to be a few less than 20. And it turns out that 18 times 18 gives us 324. So the square root of 324 is simply 18. Let's find the square root of 625. Let's see. Well, we know that, what do we know? We know that, what's 25 and 25? 25 and 25 is 625. And again, this is a lot of trial and error, but when we want to find the square root of a number, we want to find two numbers that will multiply to give us whatever we're taking the square root of. So, 25. Square root of 625 is 25. Let's find the square root of, let's say, 169. Okay, well again, we know 10 times 10 is 100, so the square root of 169 is going to be just a few more than 10 times 10. 11 times 11 is 121, so this turns out 13 times 13 is 169, so the square root of 169 is 13. Let's do one more. Let's take the square root of 256. 256. Well, we know 13 times 13 is 169, so let's just try a few more up, and it actually turns out 16 times 16 is 256. So the square root of 256 is 16. Now, taking square roots of things is actually a lot of trial and error, so just take two numbers, multiply them together, and see if they give you this is called the radicand. Don't get excited about the name, it's just what it's called. The radicand is what's under the radical, or the square root. But it's a lot of trial and error, so just try a few numbers and just get closer and closer till you get to that number. But moving on, what we really want to focus on is these we can memorize. The perfect squares, the square root of 9 is 3, 3 times 3 is 9. Square root of 16, square root of 25, square root of 36. We can memorize those because they're small. But what we want to do is we want to know what the square root of an integer that's not a perfect square. Let's say we want to know the square root of 12. There's no two numbers that we can multiply together, or there's no number that you can multiply by itself to get 12. Okay, so what we want to do is we want to rewrite this number as a product of a whole number and an irreducible radical. Wow, that is a mouthful. So let's basically, what are we talking about? We know that 12 can be written as 4 times 3. When we have a number that we want to know the square root of, but it's not a perfect square, we want to write it as a product of a perfect square and another number. 4 is a perfect square because 4 can be written as 2 times 2. Okay? So, excuse me. What we can do is we can take the square root of 12 and write it as the product of the square root of 4 and the square root of 3. So the square root of 12 equals, what's the square root of 4? Is 2. 2 times 2 is 4. And times the square root of 3. 3 is also a number that's not a perfect square, so we can rewrite, we rewrite that under the radical. So the square root of 12 is actually 2 times the square root of 3. This is our answer right here. It's the product of a whole number and an irreducible radical. This is the radical, and we can't reduce it any because this isn't a perfect square. Let's do a few more of these, just so there's no confusion. Let's take the square root of 40. Okay, let's start off with what we know. We can split this. 40 can be rewritten as 10 times 4. Take the square root of these two. 4 is actually a perfect square. We know this. 10 isn't. We can rewrite 10 as 5 times 2. It's reducible, but neither 5 nor 2 is a perfect square, so that won't help us any. But we can rewrite 4 as a perfect square. Square root of 4 is 2, and rewrite square root of 10. So square root of 40 is 2 times the square root of 10. Let's do a few more of these just to make sure we got it. Let's take the square root of 75. Okay. 75 can be rewritten as the product of 25 and 3. So the square root of 75 is the square root of 25 times the square root of 3. We rewrote this as an irreducible radical and a perfect square. 25 is a perfect square because 5 times 5 gives us 25. So we have 5 times the square root of 3. Let's do a few more. Let's take the square root of 72. Okay, 72 can be written as 8 times 9. So the square root of 9 times the square root of 8. 9 is a perfect square. 3 times 3 is 9, so the square root of 9 is 3 times square root of 8. Okay, now 8 can also be reduced. So we have a 3. 8 can be reduced to 4 times 2. So square root of 4 times 2. Just keep going because it's multiplication. And this can be rewritten as 3. Square root of 4 is 2. So 3 times 2 times the square root of 2. We can't reduce the square root of 2 anymore. So the answer to the square root of 72 is 3 times 2 is 6 times the square root of 2. What we simply do is we're writing out the factors of what we want to take the square root of, and we want to simplify it as much as we can. We want to write them out. We want to find perfect squares. We want to find factors that are perfect squares. And we can actually keep simplifying until we get a number or an expression that can't be reduced anymore. And 2 can't be reduced anymore, so that's our answer. Okay, let's do a couple more. Let's say we have square root of 200. I don't know the square root of 200 off the top of my head. So let's write out a couple of factors. We can rewrite the square root of 200 as a square root of 20 times square root of 10. 20 times 10 equals 200. Okay. These aren't perfect squares either, so we can keep on reducing. 20 can be rewritten as 4 times 5. Square root of 4 times square root of 5 is square root of 20. We can also rewrite 10 as a square root of 5 times square root of 2. Okay, now this right here tells us right off the bat that we have a perfect square, because there's two factors here being multiplied together. So we know the square root of 5 times square root of 5 is going to give us 5. Okay. Now this is also a perfect square because it's 2 times 2. So what we have is 2 times 5 times square root of 2, which gives us 2 times 5 is 10 times square root of 2. Anytime you multiply the square root of something by itself, square root of something times the square root of the same number, the square roots actually cancel out. Because remember, not to insult your intelligence, but x times x is what? X squared. Well, if we take the square root of both sides, square root of x times the square root of x times the square root of x squared, well, a square root cancels out a square. And we'll go over this in a later section. We're working with powers. But this actually cancels out and just gives us x over here. So the square root of x times the square root of x is x. So the square root of 5 times the square root of 5 is 5. We'll go over this in more depth when we talk about powers, but I just want to give you an introduction on that. Let's go ahead and do one more because we're running out of time. Let's find the square root of 27. Square root of 27 can be rewritten as a square root of 9 times square root of 3. Square root of 9, that's a perfect square. It gives us 3 times 3 is 9, so 3 times square root of 3. We should have 9 memorized as a perfect square because it's a smaller number. So 9, 4, 16, those we should all get memorized. But this is also an irreducible radical, so there's your whole number, there's your radical. This is what we want to do. So what do we learn here? Square roots, we have perfect squares. And when we want to find the square root of a perfect square, we essentially, this is how we want to start all square roots. We want to go trial and error. We want to find two numbers that'll multiply to give us somewhere in the ballpark of this number right here. Now, when we get to a number where we can't find two numbers that'll multiply to give us that number, such as 12 or 75 or 200, we'll actually write the answer as the product of a whole number and an irreducible radical. Okay, we'll work with square roots a lot more in algebra, and especially we'll go over the powers, how a square root will cancel out a square, and we'll work with that later on. But I'll see you soon. Be sure to go over this because we really want to get comfortable working with square roots.